Math and beats, videos galore. In this video, we're going to talk about the contrapositive of a logical implication. What is that? First, let's talk about a little vocabulary for logical implications. Little refresher. Recall that if we have two statements, P and Q, then a logical implication, sometimes referred to as conditional statement, involving these two other statements, P and Q, is the statement, if P, then Q. And if we could show that that's true, we would write this logical implication here. So we're going to look at that in ways to rewrite it. And you know, our whole goal in these last few videos is coming up with techniques of proof. And we encounter theorems, we encounter lemmas, you know, propositions, all these things which we are trying to prove. And one of these types of statements are logical implications. So we have to have alternate ways of approaching it, as we're going to see in this section. Now, previously we had talked about when we're talking about just vocabulary in general and dissecting statements and compound statements, when we had a logical implication, if P then Q, we often refer to P as the antecedent and Q as the consequent. So though that is the technical terms, we often use the words hypothesis for P and Q is the conclusion, mainly when we're trying to actually prove a logical implication. So it's just some vocabulary to get out the way. And then recall as well that if we show a logical implication is true, it's also the same as showing the conditional statement if P then Q is a tautology. And remember, a tautology means a logical statement which is always true. So if we could somehow construct a truth table for if P then Q and show it's always true, then we have shown it to be a tautology and that statement is true. Okay, so the thing that we really want to get into real quickly here is sometimes it ends up that showing a logical implication if P then Q is a tautology directly is often very difficult to do. Sometimes it's even impossible to do it. So it's like, well, what are we going to do? We really think it's true, but we can't figure out a way to show it's true. And because of this, we're going to introduce what's called, main topic here, contrapositive of an implication if P then Q. What is a contrapositive? The contrapositive of a logical implication to P then Q is this statement right here that I'm boxing in. Remember what that means? If not Q, then not P. So that statement is called the contrapositive of the implication. What we're going to do to begin with here is we're going to actually construct a truth table for the contrapositive of the statement if P then Q. And then maybe we notice something. So I've already got some of this table constructed for us. Remember, we want to take on all possible P and Q combinations truth values. Maybe P is true, then Q is false. Or actually, you know what? Let's begin with true. True. And then P is true, Q is false. And then P is false and Q is true, and P is false and Q is false. So those are all the possibilities. Now in this next column, not P, we're just going to negate P from the first column. So all the trues turn to falses and all the falses turn into trues. Same thing going to happen for the not Q column, turn the trues to falses and the falses to trues. And in the logical implication statement that we've already talked about previously, but just as a reminder, that statement is always true except when P is true and Q is false. So it's going to go true in the first one. True implies true. True does not imply false. So that is false. False can imply true, and false can imply false. So true, false, true, true for the if P then Q statement. Now what about the contrapositive in that last column there? Well, now we're going to be looking at these two columns right here using the not Q as the hypothesis of the statement. So again, this is going to be always true except when true implies a false. So the first one, false implies false. That's true. Next one, right here we're at. True implies false. Nope, that's false. Third one, false can imply true. True. And then finally, true implies true. True. Check it out. What this shows is something really important. And that is logical implication and its contrapositive have the exact same truth table. Right here. Contrapositive of a logical implication, we say, is logically equivalent to the original logical implication. So what that allows us to do is be able to use contrapositive to prove a logical statement, because if we show the contrapositive is true, then that would also show that the original logical implication is true, since they share the same exact truth table. And so it's very useful, and it's summarized here in this last statement. It's just another technique of proof that we're going to end up using along the way to help us prove a variety of statements, specifically a logical implication. And that is it. It's a short video on what is contrapositive of a statement, where does it come from, and how does it have to do with a logical implication. So I'm out until the next video, and then it's time for a short beat. Later.